Welcome to Chapter 1, where we are dealing with computation and numbers. This is Lesson 2 in Section 3, and that is on zero and negative indices. Now, we would have examined previously the 5 rules of indices, right? And the rule that was lesson 1, rule 4 and 5. So if you did not see that lesson, go back to it. Or if you didn't understand something, go back to it, ask questions if necessary, right? So the rules 4 and 5 dealt with negative and zero indices. So anything to the power 0, anything to the power of something that is negative, right? So the fourth rule is that a to the power 0 is equal to 1. Now, we are going to prove that this is true. Why are we saying that anything to the power 0 is equal to 1? Let's do it with an example of 5 squared divided by 5 squared. Now, if we go back to rule number 2, we know that if we have the same base, we can subtract the indices when we're dividing two terms of the same base with the same base, right? So we could subtract the indices. So we know that 5 squared divided by 5 squared is the same as saying 5 to the power 0, right? Now, what is 5 squared? 5 squared is 25. And what is 25 divided by 25? 25 divided by 25 is equal to 1. So you could see here that anything to the power 0 is equal to 1. We have proven that to be true, right? So that is proven the fourth rule, that anything to the power 0 is equal to 1. The fifth rule is that a to the minus n, so anything to the power of a negative indice or index is 1 over a to the n. So it's like a fraction, right? So let's prove this one to be true as well. So let's use the same rule that we had before, which is the second rule saying if we are dividing numbers of the same base, we can subtract their indices. So this time we're going to use 7 cubed and 7 to the power of 5. So 7 cubed divided by 7 to the power of 5. Now we are going to subtract our indices. So that's 7 to the power 3 minus 5. So that's 7 to the power minus 2. So 7 cubed divided by 7 to the power 5 gives us that negative index, right? 7 to the power minus 2. So let's go back to this original thought here. 7 cubed divided by 7 to the power 5. 7 cubed is 7 multiplied by itself 3 times, right? And 7 to the 5 is 7 multiplied by itself 5 times. So we put 7 3 times here, divided by 7, 1, 2, 3, 4, 5 times here. And we could reduce. I mean, we've done fractions. So we know that we could, this 7 will cancel this one. This 7 will cancel this one. This 7 will cancel this one. So these 3 7s cancel these 3 7s here, leaving 2 7s uncancelled. So this is the same thing. So we canceled everything here. So this is 1 by 1 by 1, which is 1. And then divided by 7, which is 1 over 7 squared. So you see 7 to the power minus 2 is 1 over 7 squared. So that fifth rule is proven. A to the minus n is 1 over a to the n, right? So all we have to, we don't have to prove this. All we have to do really is know to apply, how to apply it in any circumstance. So for that, we will go to an example. So the example says, simplify 16 by 2 to the minus 3. So how are we going to work that out? So 16 and 2, well, they are two different bases. So even if we say 16 to the power 1 multiplied by 2 to the power minus 3, we can't do anything with that. So 16 to the power 1 multiplied by 2 to the power minus 3, different bases. So we can bring this to the same base. Let's do that. Because we know that 16 is 2 multiplied by 2, multiplied by 2, multiplied by 2, or 2 to the 4. 2 twos are 4, 4 twos are 8, 8 twos are 16. So 2 to the 4 is the same thing as saying 16 multiplied by 2 to the minus 3. And now we can work this out. I will do it the long way. We could just apply the first rule here, but I'm going to do it the long way. I'm going to multiply 2 4 times. And now I'm going to divide it by 2 multiplied by itself 3 times, because we know that 2 to the minus 3, that means 1 over 2 squared. And then we could cancel off, cancel, 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 and we end up with 2. Now let's do it the shorter way. So now we go back to 2 to the 4 by 2 to the minus 3. Same base, so we add the indices. So 2 to the 4 plus minus 3. And that's, we know that plus and a minus will give us a minus. So that's 2 to the 4 minus 3. 4 minus 3 is how much? Just 1. And we know 1 is understood. That's equal to 2. The 1 is understood, right? So both ways we could get the same answer. So we just have to apply the knowledge. So here we apply the knowledge that 2 to the minus 3 is 1 over 2 to the 3. And then we divided it and we could get the answer. Here we use the first rule. When we multiply the same bases, we add the indices. We got the same answer, right? So you just need to learn how to apply the different rules and search it out. So like we searched out here that 16 is 2 to the 4. So we know we could have used 2 to the 4 to make it the same base, because we can't do anything when the bases are different. And you know, these are the things you have to critically think about when you're approaching questions, right? And that is how we work out zero and negative indices.